Alright, this is day 57 of AP Calculus with Sparks. We're going to talk about the second fundamental theorem of calculus. Alright, so given these functions we have below, we're going to use the fact that f of x equals the integral from 1 to x of f of t dt to find x and f prime of x. Alright, so for starters, let's just write it all out. F of x is equal to the integral from 1 to x of, and we have 4t minus t squared. So we take the antiderivative of that. So f of x is equal to 2t squared minus 1/3 t cubed, and we're going to evaluate that at 1 and x. So f of x is equal to 2 times x squared minus 1/3 times x cubed, and we subtract out 2 times 1 squared minus 1/3 times 1 cubed. So we've got 2x squared minus 1/3 x cubed minus 2 plus 1/3. I'm sure you guys are loving those fractions. So big F of x is equal to 2x squared minus 1/3 x cubed minus 5/3. So there is the first part we've been asked to find, f of x. And then now we need to find f prime of x. We just take the derivative. 4x minus x squared. If you're in my class, I'm sure you'd be saying, well, duh, Mrs. Goodrich, you took the antiderivative of it. Let's try it again. Now we've got f of x is equal to the derivative from 1 to x of, the integral from 1 to x of cosine t dt. We need to find the antiderivative of cosine. And the antiderivative of cosine is equal to sine, evaluated at 1 and x. Sine x minus sine of 1. Sine of 1 has a value, it's, I don't know, somewhere between 0.7 and 1. And then we find the derivative, f prime of x, and that's equal to the derivative of sine, which is cosine x. And again, you're going, okay, that makes sense. Well, now let's do the same process, but now we want to go from 1 to x squared. So f of x is equal to the integral from 1 to x squared of t cubed dt. We need to find the antiderivative of that. And evaluate it at 1 and x squared. X squared to the 4th minus 1/4, 1 to the 4th. Is what 1/4 x to the 8th minus 1/4, and then f prime of x is equal to 2x to the 7th. Well, wait a minute. What the heck happened? Let's try it again. F of x is equal to the integral from 1 to x squared of 6. I'm going to rewrite that as t to the 1/2. And then we take the antiderivative. So what is that? That is 4t. So f of x is equal to 4 times x squared to the 3/2 minus 4 times 1 to the 3/2. And we have f of x is equal to 4x to the 4th minus 4. And then f prime of x then is equal to 12x squared. The heck happened, Mrs. Goodrich? It doesn't look like the same pattern we had above. It is the chain rule come back to haunt you again. So the second fundamental theorem of calculus says, if f of x is equal to the integral from a to some function g of x of f of t dt, where a is any constant, then f prime of x is equal to f of g of x times chain rule g prime of x. I don't know what your page says, but this should say page 591. It's the page right before the one we're on. So we're going to complete this table. We're going to do what it's asked and then also what we did. So for f of x from the previous page, for the first one, we had f prime of x is equal to 4x minus x squared. And now let's apply the second fundamental of calculus, which says that f prime of x can be found by plugging this in here. So that's 4 times x minus x squared, and then we need to multiply that by x prime, which the derivative of that is just 1, which gives us 4x minus x squared. Let's try it again. F of x equals the integral from 1 to x of cosine. That one we had that f prime of x is equal to cosine x. Well, now we'll apply it using the fundamental theorem of calculus. We're going to get, plugging this in for t, so equal to cosine of x times the derivative of x, which is 1. Now let's try what we have x squared. So from the previous page, this is the one that surprised us, we have 2x to the 7th. And then when we do it using the fundamental theorem of calculus, we're going to plug this in there. So we're going to get x squared to the 3rd, and then we have to use the chain rule to take the derivative of x squared, which is 2x, which gives us x to the 6th, 7th, 2x to the 7th. It is, of course, acceptable to go the long route, but this is kind of just a shortcut. Let's see. F prime of x for this one was equal to 12x squared when we worked it all out. We apply the second fundamental theorem of calculus. We're going to get f prime of x is equal to 6 times the square root of x squared, and then times the derivative of x squared, you get 2x. So we have 6x times 2x, which is 12x. Let's try it again. Why don't you guys give these a try? E to the cosine t. Okay, why don't you try the first one, and then we'll check our answers, and then we'll come back to the second. So pause the video right now. Alright, so you plug 2x in for the t. Simplify, make sure you multiply by the derivative of 2x. And you end up with 2 times the square root of 2 minus 4x squared. I'm going to go ahead and work through this one, but if you want to try it on your own, pause it now and check your answer. Alright, so the first thing I notice is that we have these things flip-flopped. And we can't have them flip-flop because our second fundamental theorem of calculus doesn't say anything about flip-flopping. So let's flip them back over. G prime of x, actually let's do g of x, is equal to the opposite of this. Remember that rule? You can flip-flop the limits as long as you change the sign. So then g prime of x is going to be equal to the opposite, and the antiderivative e to the cosine t, the integral of e to the cosine t, we're going to plug in x squared, and then chain rule says we have to multiply that by the derivative of x squared, and we get that. So this is equal to negative 2x e to the cosine x squared. It really wasn't that messy, it's just I knew some of you would be freaking out. Alright, see if you can try that for h of x. You could pause this now and check your answer. Pretty straightforward. You plug in cosine for t, then take the chain rule, and so you take the derivative of cosine, and you end up with negative cosine squared x times sine x. Alright, picture to the right is the graph of g of t, and the function f of x is defined to be the integral from negative 4 to 2x of g of t dt. First thing, find the value of f of 0. So f of 0 is going to be equal to the integral from negative 4 to 2 times 0, which is just 0. G of t dt. So now we're talking about the area under the curve between negative 4 and 0. So there's negative 4 and 0. And this area is going to cancel out their area, that area. So we end up with a quarter circle pi r squared, and this is a rectangle base times height. So then f of 0 is going to equal to the area of the rectangle, which is 2 times 1, so that's 2, plus the area of a quarter of the circle is 1/4. Pi r is 2, which is equal to 2 plus pi. Alright, you try number 2 on your own and check your answer. Pause it now. Alright, so what I notice is this is an even function, which means I only have to find half the area, and I've already done that, because I already found this quarter circle, and this base times height, and I multiplied that by 2, and I already had the answer, so I used what we already did, and I got 4 plus 2 pi. Now we get to use that second fundamental theorem of calculus. So we know that f of x is equal to the integral from negative 4 excuse me, to 2x of gt dt. So f prime of x is going to be equal to g of 2x times the antiderivative of 2x, which is 2. We got to do that at 1. So f prime of 1 is going to be equal to g, I guess there's a 2 out front, 2 of g of 2 times 1, which is 2 g of 2. So this is going to be 2 times whatever g of 2 is, and this is the graph of g up here, so g of 2 equals 1. Let's try that again. Now we want f prime of negative 2. We already know that f prime of x is equal to 2g of 2x. So f prime of negative 2 equals 2 times g of 2 times negative 2, which is 2g of negative 4, which is 2. And then if I go back up here and look, negative 4 is down at negative 1. 2 times negative 1, which equals negative 2. What? Double derivative? Well, we already know what the first derivative is. Let's go find the second. So f double prime of x is going to be 2. And then we have to take the derivative. Excuse me. So we know g prime of 2x, and then chain rule says we have to take the derivative of 2x, so that's 2. So we have, 4 g prime of 2x. So f double prime of 2 equals 4 g prime of 4. What is g prime of 4? Well, 4 is an endpoint right here. Which means it's not differentiable. It has to be continuous at that point, and it is not. D, N, E. Let's try it again. G of x is defined to be the integral from -1 to x of f of t, and this is t. Right here. Now, g of -6 is going to be the integral from -1 to -6. And since those are not in the order we like, we're going to change that by changing the sign. Now we need to go find the area of the curve from -6 to -1. This will be the positive area. This right here is going to be negative. We should find a new color. That looks like a trapezoid and then a triangle. So g of -6 is going to be equal to 1/2 the base, which is 2 times the height. 1, 2, 3, 4. And then we subtract out. Let's see, baseline is 3 into 1/2 the height, which is 2 times 3 plus 2. And when we work all that out, we should get 1. Don't forget there's that negative out there. This ends up being 4. Negative 4 minus 5. And that's where we get -1, which is 1. Alright, you try this one, and we're going to find g of +6. Give that a try, and pause it, check your answer. So, the trapezoid is negative. That ends up being area of -8, and then the circle is a quarter circle, ends up being pi. You get -8 plus pi. Let's find g prime of 6. Since we know g of x is equal to -1 to x, then g prime of x is going to be equal to f of x times the derivative of x, which is just 1. So g prime of x is equal to f of x. So g prime of 6 is going to be equal to f of 6, which if we go to our picture, we get that is equal to 2. And number 4, just look at the graph. G prime of 2 equals f of 2, which is equal to, what's a 2? Equal to -2. And double prime, so g prime of x is equal to f of x, so g double prime of x is going to be equal to f prime of x, and we want to know what happens at 2. So g prime at 2 is equal to f prime, g double prime of 2 is equal to f single prime of 2, and if I look at our picture, f of 2, the slope's going to be undefined because that is a cusp. There's a cusp at x equals 2. Actually, it's t, isn't it? Alright, and same thing of 4. So g double prime of -4 is going to be equal to f single prime at -4. And at -4, we can find that slope. Let's see. 1, 2, 1, 2, 3, 4. That slope is -2. The slope of f of t at t equals -4 is equal to -2. And that is the end of this video. You have a discussion page and some homework. I will catch you guys later. Bye.